Hi class, this is Professor Teixeira. In this video, I'm going to show you how to work on single period inventory models. And this type of models, they're designed when you have one like event for selling. For example, like a sports event or like a newspaper or like a t-shirt for a specific event. If you don't sell those units in that specific day, you can sell them later, but with a loss. Okay? So this is the type of problem that the single period inventory model is designed for. That's the reason it's single period. It's only one time. Okay? And typically what we have is a problem in which let's say the company knows the probability of certain demand based on the past. So based on past events, based on past opportunities of selling the product, the company could collect data and knows the probability. Okay, let's take a look at this problem and solve it. Rick Jones is chairman of this year's Walk of for Diabetes event. Each year, the organizers of the event typically have commemorative t-shirts available for purchase by the entrance in the walk. Rick needs to order the shirts well in advance of the actual event. He must place his order in multiples of 10, like 60, 70, 80, and so on. Based on past walks, the organizers have determined that the probability of selling different quantities of t-shirts in a given year has this distribution. Okay, so that's the amount of demand and the probability of occurring this demand. So here we have some information. Rick plans to sell the t-shirts for $20 each. That's the price. He pays his suppliers $80 for each shirt. That's the cost. And if he cannot sell the shirts during the event, he sell unsold shirts for $2 with a loss of 6. I'm going to show you, okay? So to get started, I'm going to copy this data here. Let me copy this data, go to Excel, and let me paste. Let's paste, okay. Okay, let me copy this again and paste here, transpose, paste, transpose. Okay, that's how I want the data to be. Okay, so let me delete the cells. Okay, we have the demand for t-shirts and the probabilities. Okay, and let's see, we have to come up, the way the textbook teaches this solution is by a payoff table. So we're gonna come up with this payoff table. So instead of like typing all this data, I would type, but to save some time, I'm gonna copy and paste here, okay? So I'm gonna have the number of t-shirts ordered, and here's the demand. This is how much it's ordered, and here's how much it is the demand. Okay, I'm gonna fill out this payoff table, and that's how we're gonna solve the problem. But before doing that, what I want to type here is the price that I just mentioned was given in the problem. Let's take a look again. The price plans to sell the t-shirts for $20. So $20 is the price. He pays suppliers $8 for each t-shirt. So the profit is the difference between 20, the price minus the cost. That's the profit. Okay. And we also know that any remaining t-shirt unsold sells for $2. So let's say sale price is $2. So the loss is equal to my cost minus my my profit. Okay, I'm sorry, my cost minus my sales price. Or to make it negative because it's a loss, is my sales price minus the cost. Okay, so that's a negative, a loss of $6. All right, now to fill out this table, we have to check two situations and do the math. Okay, I'm gonna do it some of them or probably all of them so you figure out how to do it. So here is the number of shirts ordered. Okay, let's say Rick ordered 80. And the demand, we don't know, but let's assume the demand in the day of the event was 80. So everything that he ordered, he sells for the price he paid for. Okay. So what we do the demand times the profit. Okay. Now let's move to the next one. He orders 90, but the demand is 80. So he's gonna sell 80, and the 10 remaining, he's gonna make a loss. So how this is going to be? This is going to be, look, the number of shirts order is more than the demand. So he's gonna sell at most what the demand is for the price it's charging, which is $20. So if he sells all the 80, he's gonna profit 80 times the profit. Okay. But we have to add the loss. How much is the loss? Is the remaining amount not unsold times the loss. So how much is the remaining unsold? He ordered 90 and the demand was 80. So unsold is 10 units. So there is 10 units that he couldn't sell. Now we multiply these 10 units by the loss and we add to this amount. Is $900. Okay. Now we keep doing that. One more time. He orders 100. The demand is 80. So he sells all the 80 for the full price and make this amount of profit. But he has 20 because now it's 100 minus 80, 20 unsold. So it's 20 times the loss. One more time. He orders 110 and the demand is 80. So he's going to sell all the 80 for the full price and making this profit, 80 times 12. Then we have to add, let's say I don't want to do like in my mind the computation. I can also open parentheses here and do this, 110 minus 80, which is the difference between what he ordered and what he sold. This difference is the unsold t-shirts. Then we multiply by the loss. Okay, one more time, let's do it. So he orders 120 and the demand is 80. So he sells all the 80 for the full price, making this profit, but we have to add the difference of 120 minus 80, which is the unsold, times the loss. Okay. Now we keep doing that. So let's go back one more time. Now it becomes boring, but let's do it. Number of shirts ordered 80. The demand is 90. Well, he ordered 80. He's gonna sell 80 because he could have sold more, but he didn't order 90. He ordered 80. So now I get this 80 from here times the profit, and that's it. He doesn't have any unsold. He has lost like sales. He couldn't sell more. Okay, now let's do 90 and 90. He orders 90, he sells 90, the demand is 90, multiply by 12, it's over. Now this, he orders 100, the demand is 90, he multiplies by the profit, but he has to add the remaining 10, the difference between 100 and 90. Let me do it. 100 minus 90 times the loss. Okay, let's do one more time. So he orders 110, the demand is 90. He multiplies by the full profit, it is 90, but he has to add the loss, which is the difference between when 10 and 90 times the loss. Let's do one more time. Now he orders 120, he sells 90, he multiplies by the profit, plus add the loss, which is the difference between 120 and 90 times the loss. Okay, so what I'm gonna do here is, for this first row, is always going to be 960 because he orders 80 and the demand is always higher. But because he doesn't have more to sell, he maximizes in 80. So here he orders 80, the demand is 100, he sells all the 80 and that's it. Okay, I got the wrong cell here. So let's make it faster. Now I'm gonna I'm gonna lock this cell. Cell, okay, I lock this cell, and then I have to lock both cells, right? Yes, I have to lock both cells, and then I can simply copy, and it's done. Why? Because he always orders 80 and the demand is always more. So he sells all the 80. He has some lost sales, but we're not computing the lost sales. It's the same thing for the 90. Everything here is higher than 90. So I'm going to repeat the same profit, 90 times 12. Okay. So I'm going to lock all the cells just to copy them. He always sells all the 90 t-shirts ordered. He doesn't sell more because he doesn't have it. Here, the same thing. He's going to sell all the 100. Here, he's going to order 100. The demand is more than that. He's going to sell all the 100, 100. That's it. The same thing here. So let's do it. 100. He orders 100. The demand is 100. He sells everything. Let's lock the cells. Copy them. Now it changes a little bit. He orders 110 shirts and the demand is 100. So he has some unsold. So the demand is 100 multiplies by 12. And then we have to add the difference, which is 110 minus the actual demand times the loss. Okay. Now what we have here is the number of shirts ordered is the same as the demand. So I can pick any one and multiply by 12 because he sells everything. He doesn't have any remaining. The next one, I'm going to lock these cells and just copy because the next combination, he orders 110, the demand is higher, he sells on all 110 and that's it. Now, he orders 120, the demand is 100, so he's going to sell all the demand for the full price and profit, and we're going to add the loss of 20, 100 minus 120 minus 100 is 20, one sold, times the loss. Let me do here one more time. So he orders 120, the demand is 110, he sells all of them, plus the loss of 10 units, that's the difference between these two guys is 10, times the loss. Finally, he orders the same amount as the demand, so he sells everything for 12. Okay, beautiful, right? Now what we have to do is we have to come up with the sum product of these probabilities of this, I'm sorry, these profits times the probabilities, okay? So let's do these expectations. In fact, this is called expectations, expected profit, given the probability. So what we're going to do is use the sum product function. It's like this, equal sum product, open parentheses. Then I have to select the arrays I want to make the product and sum. So when I select this row and then I type comma, then Excel is highlighting, I have to select the other row, okay, and then close parentheses. So what Excel is doing for me is multiplying 0.2 by this number, multiplying 0.25 by this number, and so on, and then adding all these products. That's called summing the products. Beautiful, right? So, okay, that's the sum product of this first amount. When orders 80, the expected profit is this amount. So I'm going to do that for all other rows, but I want to lock this probability range here. So I come here on top, I click on this formula tab, I highlight the blue one, that's the one I want to lock. I come in front of it and I type the dollar sign in front of the letters and the numbers for that array. The OK is locked. Now I can simply copy the function, go to the bottom, click just to check that the probability is still like locked and I'm getting the last row, which that's what I was expecting. Okay, so now what is the job? I have to figure out which amount of shirts ordered has the highest expected profit. So the highest expected profit is this one, is $1,083. So that's all expected profit based on the probabilities from the past. That's how we try to minimize the mistakes of ordering and having losses. Okay, so the number of shirts that Rick should order in order to maximize the expected profit is 100 shirts, considering this price, this cost, and this sales price and loss. Okay, so that's how we do it. Let's take a look. If we take a look, that's the same payoff table we have here, 1,083, 1,083, everything beautiful. Of course, you can format to make it look beautiful, fancier, beautiful, okay? But that's all. All right, this is more talking about the solution. There is a problem here. That's a very similar problem. I don't know how long this video is. I can work on that, but it would be the same thing, okay? There's nothing different for these types of problems. So I'm going to stop here, let you practice on this one, and you let me know if you have any questions, okay? Okay, bye guys.